Hello, we are Team Why So Fearious. This video is a demo video about the early prototype we made for our project Breakfear. First, let me introduce the projects that we are working on. Breakfear is a walk-in kitchen space that full of fear-based punishment systems that aim to help people to make a good choice and living in a healthier morning routine. This is an user-friendly project. The target user group is people who want to have a good, healthy morning but lack of motivation to do it, and also motivated by consequences. The space that we are focusing on is kitchen space, because breakfast is one of the most important elements to form a healthy morning, which is also how we got the name Breakfear for our project. Ideally, users will enter the kitchen space and interact with items that in the kitchen, such as toaster, fridge, kettle, etc. Depending on the decisions that users made, various consequences will be caused by the user movements. Obviously, if users make an unhealthy decision, then the function of the fear hiding inside all the kitchen items will be triggered. Users will receive the uncomfortableness or fear as the consequence response. By receiving this negative response, users would like to make healthier decisions next time in order to prevent the increasing of friction level. Then, because of the awareness of consequences, users could gradually learn and forming a healthier morning habit. Now, for the demo part, we will present the two items that we are recently changing on. One is the toaster, the other is the kettle. The demo will show the interaction first, and then other team members will expand the detail of what we did to those two items.
So for the toaster, we basically modeled this so that it doesn't activate the heating element when you push this down. So when you push it down, it doesn't activate the heating element, and after a certain amount of time, it will turn up. So the way we've done this is it's basically to the main.
So we've disconnected the heating wires, so that way we're only looking at the magnet that actually holds down the lever here, so that we're still giving off the impression that the toaster is like working.
And so the idea with this one is so we have like little objects, like insects or something, get in here, so that when the user says puts toast in here, and they put it in there and it comes up, these objects will pop out and give them a bit of a scare. And so this like further reinforces the user-friendly aspect of our design. And also when the as like a complement to it as well, we have like sounds that will play when the toaster disengages, and as those things pop up as well.
So as mentioned before, our user testing explains that tactile audio is the most disturbing way to when they approach fear, because that's the one that affects them the most. So we use those into play. The first thing you can see is, so I use Play-Doh and then I use like this probe. If you know like a probe flip, I just make holes on them, which can trigger some fear for some people. Currently it's not in color, actually you see how that blends with the different types of textures. So we did user testing on textures. One of the answers, Velcro is kind of disturbing, so we did include this Velcro inside the handle. I feel like when you pick up a kettle, you don't really think about what it feels like, you kind of know what to expect. So this just disturbs that flow of movement. Another one that we made user-friendly is that the kettle is extremely heavy. So there is an ankle weight, 1 kilo ankle weight, and some pebbles inside it that although water is heavy, this is extremely heavy, and that the water just get taken back and they can think about what's happening. With the kettle, similar to a toaster, we remove the heating. It doesn't turn on, but we do take advantage of what is already in the toaster. So the circuit that's already, in the kettle, the circuit that's already in the kettle, we can detect, we can read when it's turned on, turn off, and that's when the audio also plays into the experience. That's and the audio is also the audio from the user testing that we did. I think we had 7 audios that plays into the experience.
So both of these appliances are basically in our findings that we're part of a larger kitchen space. So the idea here is just to give an idea of what our interaction will be, how we'll go through that. And yeah, so it's just an idea to show off the elements we have and it's going to be transferred. for the user.
We have adjusted our intended experience to fit what we have built for the live demonstration. In this case, the intended experience for the kettle is that when the user turns on the kettle, there will be audio that pops up alongside the tactile experience of the kettle shell and the handle of the kettle. While the toaster, when the user turns it on, it will pop up unexpectedly. More explanation on this will be discussed later. The adjusted use case of the live demonstration is that when a user are making toast and coffee using the toaster and the kettle in the morning. These interactions will allow them to have a friction in their morning routine that provides time to make a decision, albeit if it's a healthy or unhealthy decision. For the live demonstration, we prepared a setup that ensures the user can feel like they are in their kitchen, complete with a plate and a mug. The use case is adjusted for the final exhibition by ensuring that there are options for the users to make good or bad decisions. Furthermore, we will enhance the signifiers to push the users through a series of steps on how to complete the morning routine. This will allow for a clearer goal of the experience.
So for this prototype, we managed to get two appliances working. So we have our toaster component, which will lock into place like a normal toaster and launch out insects that are placed inside to give the users a jump scare as they're using it. And then our second appliance is the kettle, which has a series of textures applied to it to cause discomfort. And when the users use the trigger for the switch the kettle on, a series of sounds will play through our unit.
The toaster part of the prototype is connected through a 2 relay module to magnets of the toaster, completing a circuit between the Arduino board, the power supply, and the toaster nut. The wiring of the magnet allows for the magnetism to be toggled on and off with the relay, without the heating element of the toaster being enabled. During the prototype, the relay was set to have a 5-second interval where the magnet was able to connect to the other magnet before disengaging in the same amount of time. This was purposely done to ensure the toaster would pop and lock like a regular toaster. The circuit with the toaster also sends a signal to an attached computer to indicate when the circuit is complete and not complete.
The kettle part of the prototype is a simple circuit that completes with the Arduino when the kettle switch is set into the on position, and it sends a signal to the connected PC. During the prototype, the kettle is used as a source of audio triggers within a Unity scene to provide audio stimulation to discomfort the user. To add a tactile experience, we also added textures to the kettle, located on the inside of the handle and on the outside shell of the kettle. The inside handle of the kettle is lined with Velcro to create an unexpected feel, while the outside of the kettle is wrapped with Play-Doh that has been pressed in with a pearl clip to create a circular dip pattern, and is coated with hairspray to harden it and provide a similar experience to the Velcro. To add even more discomfort, we added weights within the kettle, which include a 1 kilogram ankle weight and some pebbles to create an even heavier experience.
We chose to present the kettle and toaster for our prototype because we wanted to test some of the ways that we intend to use fear within the experience of our final product. While the product do not directly correlate with our intentions of guiding users to make healthier habits, these functions demonstrated within the prototype are useful in understanding the effectiveness of our type of scares and discomforts that will enable the users to overcome these obstacles to help to develop the better morning routines. We have designed these prototypes to create a friction within their morning routine. This is done so that the users have the space and time to elaborate on their decisions. Hence, it will lead to a healthier morning routine based on good decisions.